cloud. Okay. So I have started recording the class. So today I will cover first half of the data analysis and data mining. Around 40 problems. I have uploaded the problems and documents is in there. I see at least 2 faces who took courses with me before. You and you, right? You took courses. Did you take course with me? Or what course you take with me? Did you take course with me? 580? Or 5, you took 580 with me or 435?
200. Yes.
200?
Yeah.
But you are remote then, right?
No, I didn't put.
Okay. I did. Okay. So that means if you take the 200, this material you already did. Okay. This is a very fundamental material. But let me see if I can give you something new, if you are interested to do something new. Okay. So I will remember you by your name. Your name is Grace, right? Your name is Grace, right? Okay, now I remember, yeah. Now I remember both of you. Okay, so let me start downloading the material. Okay, so after downloading the material, let me first read how to solve the homework 1 problem. This is actually homework 2, okay? This is actually homework 2, but I have written here homework 1. So thoroughly read the class practice document updated at least 2 times before running or writing any code. Do not spend more than 30 minutes in reading that. So what document? Class practice document updated, which I just downloaded. So let me go there and open it from there. Downloaded. This is the document that I wanted you to read thoroughly. If you do not read these things, then there will be a problem of solving the homework. Okay. So first instruction that I gave to you, this is the instruction that I give to you. Thoroughly read the document, class practice document updated. So what is that document? This is the document. In these documents, there are altogether 70 or 80 problems. Okay. So today we are going to cover maybe 40 or 50 of this problem. Clear, right? You need to read these things multiple times so that you would not have a problem in solving the homework problem. So that is the first instruction that I give. Read attentively each problem from homework 1 document. So homework 1 document, let me open the homework 1 document. This is the homework 1 document. So in this homework document, how many problems are in there? There are 30 problems, right? So why I ask you read these 2 documents thoroughly. So the problems is coming from that document. Okay. Are you seeing these 2 documents in here? Are you seeing 2 documents in the download folder? One is called class practice document updated and homework 1. Right? So if you do these things, if you read these things thoroughly, then you will find the matching problem in here. Clear, right? Okay. After this, after this, now take a pen and match the similar problems between homework 1 documents and class practice document updated. Okay, you say that problem number 7 in class practice document is equal to the problem number 2 in the homework 2 document. Clear, right? In that way, you will match. And after 2 times in-depth reading of the above documents, watch first video and second video. Link is provided in Western Online. Open Spider from Anaconda and then open the Python code. So now I'm going to do this one for yourself. So for example, if I go there and then hit Anaconda and then hit in here, Anaconda is going to be opened. So from the Anaconda, we just want to open the Spider, okay? We want to open the Spider. Spider is opening now. My Spider is open, okay? So now I provided a Python code, right? So let me go and open that. Open. Are you seeing py file? The highlighted one, it is written there, py file, right? Python file. Here py is written there. Are you seeing py is written there? This is the py. So I click, select this and open. So that is the file opened. Understand? Okay. That is the file open. So now take a look what I'm doing. I want to go there, open the class problem. Here. This is the problems that I'm going to discuss today. Okay. So half of this today I'm going to discuss. And your homework, first homework is due on the when? Next Tuesday, right? Okay. This will be homework 2, but accidentally I put here homework 1. Okay. This will be homework 2, but I will change it. I will change it, name and everything. So what does this document telling? A longitudinal data name class practice data CSV is simulated with the following variables. So it is a variable name ID stands for identification number, race, where Caucasian is 1, Caucasians means white people, and African American means black people. So race has a 2 level, 1 and 2. There are some missing values. Income is a family income. It has a level up to 9 levels. So 1, 2, 3 up to 9. 1 is the poorest and 9 is the richest level. Okay. Age of the person, smoking is a status. If smoking has a level 1, then the person is a smoker. If the smoking has a level 2, the person is not a smoker. SBP stands for systolic blood pressure, DBP stands for diastolic blood pressure. What is the difference between them? If you take your blood pressure measurement, okay, so blood pressure machine give 2 reading. One is high, one is low. High one is called the systolic, low one is called the diastolic. Understand? So if a person has a high blood pressure, both of reading is high. If a person has a low blood pressure, both of this reading is low. Clear, right? Okay. HT stands for height of the person. WT stands for the weight of the person. WM is the waist measurement, so that means this measurement. Okay, this measurement. And BMI is the body mass index. Visit is the number of visit. So what is longitudinal data I'm going to discuss later. Well, let me discuss in here. Visit means how many times a person is visiting. So suppose we are here altogether 19, right? So today, our height, weight, body mass index, systolic, diastolic blood pressure, and glucose level, all of this measurement have been taken. Okay. Then next week again taken, and next week again taken. When next week taken, suppose 3 people did not show up. When week after next week again taken, another 3 people did not show up. Understand? Or 2 people did not show up. So if a data has a repeated measurement, that means same person is measured multiple times over time. Same people are measurement are taken multiple times over time. That data is called the longitudinal data or panel data. Understand? You understand? I write here longitudinal data, right? Longitudinal data, or it is also called panel data. It is called longitudinal data or panel data or repeated measurement data. Okay. So visit means how many times a person is visiting. Sugar means sugar level. Chest measurement is called the breast. Hips measurement. Arms, that means measurements of the arm circumference. TC stands for total cholesterol. Okay. If you eat lot of red meat, then when you become 50 or 40, you will have to take cholesterol medication, calcium carbonate. Okay. Cholesterol, TZ, triglyceride. If you eat lot of fried food or maybe cheese, something like that, fries, then you have a triglyceride. Okay. High density lipoprotein, HDL, low density lipoprotein, and pulse rate. That means this pulse rate, waist category. Waist, that is a circumference, and that is a waist category. That means that measurement has been transferred to a categorical measurement. N log means number of login. Now, if the person is using devices, how many times he is logging to the devices in each day? Okay, or each time when he visited, he was asked in last 1 year how many times you logged into your system, something like this. And time of an event or censoring, time of an event. For example, if the person is followed and up until an event happened. So what is the event? Event means high blood pressure. So you went to the doctor said that, well, your blood pressure is high. So for the first time you came to know that you have high blood pressure, right? That is what known as the time to event. Okay. So event is an indicator variable. Is blood pressure yes or no? Something like this. Data has been generated in such a way that most of the data analysis, data modeling, and test of hypothesis can be conducted with this data. So that is the highlight. Okay. Now we will go for coding part. Okay. What I did, you remember, I opened the anaconda and then I open the spider. After opening the spider, I give you a Python file. That Python file has a name. The name is that part_1_data_analysis and data_mining_updated. Okay. That is what I have provided in the Western Online, all the code. So when you do the homework, you open this and make changes in this file. That will save your valuable time. Do you understand what I say? If you are not a good programmer and want to waste your valuable time, then what you are going to do? You are going to do these things. You are going to open a new one. Okay. If you do not want to listen to me, if you want to waste your valuable time, you just open a new one, then you will go there. Okay. Okay. Copy this and paste it in there. Okay. Copy this and paste it in there. Okay. Copy this and paste it in there. Okay. Don't be an inefficient person. Okay? What you will do everything in here. Okay? Clear? Okay. So now this is the packages. Okay? These are the packages, that packages. Let me tell little bit about the Python. Python was developed in 1990 and 1991 in Netherlands. Okay, it was developed in Netherlands. And the guy ultimately came to the USA, and he was working in Google, and now I think he is working in the Microsoft. Okay. America has a philosophy. America always bring talented people in their country. Okay, are you seeing in the southern border people are coming in and thousands of hundreds of thousands, right? But America has a philosophy that it is a country of immigrant, so they cannot kill people in their border. You understand? You might not see this type of thing in the rest of the world. Okay, because American President Obama said, and also their philosophy that as a country of immigrant, we always in favor of the immigrations. But anyway, there is a controversy about other things. We are legal, illegal. I'm not going to that point. But I want to make sure one thing. If you are talented person, this is the country where you can flourish. Understand?
Yes, sir.
Sky is the limit. Let me tell you one more thing. Canada is next to USA, right?
Yes.
And Europe, America is flourished like last 400-500 years, but Europe is flourished like more than 1,000-1,200 years ago, right?
Yes.
So then in Europe, Protestant and Catholic, they are fighting, and then Catholic people be killed, Protestant come to this country and establish this country, right? This is the long history short in one sentence, right? But take a look at one thing. I want to give this opinion to you so that you understand. Europe have lot of companies: Mercedes-Benz, BMW, Siemens, Airbus, right? Can you show me one company that has a immigrant generation CEO? No, right? How many in the USA? Law just came from other country to here, landed with the 2 bags, work hard, and they will go up. This is the only country. Canada live next to US, right? Huge country. How many people are immigrant generation CEO? 0. I don't know any people. Understand? So keep this in your mind. This country is so generous. It has little problems, this and that, but in their website, Department of Labor website, it is written, an immigrant has 3 times higher chance than a citizen of this country to open a new business. Can you believe it? Yes. Department of Labor website. Yes. Okay. So I told you little bit why Python was developed in Netherlands, but the guy has potential. America said that, come, we will hold you. Okay. Similarly, R was developed in Auckland, New Zealand. That guy is now in USA. Okay. So in this country, just work hard and be honest, truthful. Work hard, be honest, show your work to your manager, and you will go up. Okay. So you have seen, I have written line number 5, 6, 7. These lines representing the packages developed by some other people, so that our tasks become very easier. Okay. So the things that you are saying, import pandas. Pandas is a package. Numpys is a package. OS means operating system. Okay. We are importing these things. And then now I am writing in here. I am running the line number. Now I am running operating system, asking me when line was run, I found this is now my working directory. Okay, this is my working directory. Understand? Working directory. So I want to change my working directory. How can I change it? I want to change it in this format. I want to change this. Take a look at that. This is my current working directory, but I want to change it my download as my directory. This is my download folder. Are you seeing download, right? So I click on there, right click on there, okay? And then I go to the properties and then I copy these things, just these things. Okay, copy these things. I just copies these things. And after doing this, now come in there. I want to change in here. I want to change in here D1. And then I want to write here, not D1. Actually, I want to write it in here. Let me put it in there, Control V, and then C. I want to user MC24, and then I will go right here, just downloads. Let me check. Downloads. Understand? So on line number 14, I make a change. What I did, OS change CHDIR. CH means change, DIR means directory. Operating system dot change directory. I declare that C colon / user MC264 download folder will be my working directory. Okay, so now let me run it. I run this one, and after running that, my data has been saved in there. The line number 23 now I run. So pd.read_csv class practice data is now run, and it has a name now D1. Clear? Are you understanding? So once you finish your degree and start working in any company as a data analyst or junior data scientist or a predictive modeler or a quantitative analyst, first task, they will give you the data. Data could come in a text format, data could come in a CSV format, data could come in any other format like SPSS file, SAS file, or any other file. Okay. So all of those packages, how to run those code are immediately available in the online. You just need to search Python code for running SAS data, Python code to run SPSS data, Python code to run R data. If you write these things in the Google will give you immediately everything. Understand? Nowadays, knowing coding or become a programmer is not a big skill set, because now everyone can become a programmer because everything is available in online. But previously, 20-30 years ago, there are few thousands programmers all over the world. Because during that time, 30 years ago, people write program by looking at the book. Okay. So by searching in the book, finding the code, writing it, trial and error, internet was in there, and everything was compiler based. You have to install the software in there, was very hard. Clear, right? But now, anytime, anything, how to do these things in Java, how to do these things in SAS, how to do these things in, then immediately you will see bunch of steps. Clear, right? Okay. Now, we already did this part. Set up working directory. I set up the working directory, right? First question I already did. And then second questions, I did this one. Read the class practice data to Python and denote it as a D1, which I did it. Now, let me start doing other thing step by step. Question number 3 is asking you check the number of observations. That means data sets has how many rows and how many columns. Okay. First of all, let me show you the data. So D1 dot head, if you write like this is the data. This is the data. Okay. D1 dot head, if you write the data, the D1 data has this type of ID, race, income, age, small variable. Some of the other variable dot 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 is in here. We did not mention it, but there is a way. How many variables you want to see? If you can specify that by writing maximum variables, then it will show. Down the road, I can show that one. And this is the last few variables, that means column. Okay. So if I want to clean these things, just Control L, it is clean. So the console is clean if you hit Control L. Okay, now how many rows in the D1 data? D1 data has 20,900 rows and 25 columns. Clear? So that is the problem number 3. Clear, right? Problem number 3, that is. Now, problem number 4 is asking you sort the names of the columns variable of the D1 data by ascending order and name as S1. Okay, so take a look at this. Take a look at this. What is the question was? Take a look at that. It starts with the I, and then it starts with the letter R. Again, it starts with the I and A, but I want it as a ascending order. The variable that starts with the letter A will come first. Understand? In that way, you can easily identify variables by name. Clear, right? So how can I do that? That is the question I mentioned in here. Sort the names of the columns of D1 data by ascending order and name as S1. Okay? Name as S1. Yeah, you can come and sit there. Okay. So now I just want to run this one. This one I ran. Now take a look at that. S1 dot head. S1 dot head. If you are you seeing now A is coming first, arms coming second, everything is now in alphabetical ascending order, right? So what I did, D1 data I take and dot sort by index, axis equal to 1. Axis equal to 1 means by column. Axis equal to 0 means row. Okay, and ascending order true. So now it has been in ascending order. Clear, right? Now sort the name of the columns of D1 data by descending order. If you do the descending order, that is the descending order. So now if you write S2 dot head, now it is descending order. Are you seeing? Okay. Now ascending and descending done. Question number 6, sort S1 data by age variable. Now what I want to do, entire data I want to order in such a way that age variable are you seeing their age variable? 9.35, then 10, then 11, all of this going like that way, right? But I want to do it in such a way that 9.35, 9.0, 9.1, 9.2, yeah, everything will be ascending order. How can I do that? That could be done by D1 dot sort values. Previously D1 dot sort index, that means index means by column name, but now take one column and sort it by their values. What is the name of the column? Name of the column is age. Are you understanding? Okay. So if I run this, and then if I take a look at this one, S2 dot head, S2 dot head, are you seeing age variable now? So see, this ID and that ID is different, right? This ID and that ID is different, but age is coming in ascending order. Understand, right? So the 80 data analysis and data mining problems that we are doing in first week 2 and week 3, if you become an expert on this and understand all of this code, then like majority task of your data analysis or data scientist job will become easier. Okay. I also have same problems R code. R versions I also have available. Okay. So question number 7 is asking you short S1 data frame by ID and age variable. Now I want to do it for the 2 variables. First sort it by ID, and after sorting ID, then go to the age. Okay, 2 variables. So take a look at that one. I sort it in this format. And then if I take a look S2 dot head, if you take a look at that ID variable, first I put the ID, same ID, right? Same ID, because same persons, he is appearing at age 9.3, 10.3, 11.28, 12.28. Once in every year, the person is appearing. Why? The same person, because ID is same. Are you understanding? I will also upload this lecture video to the online. So in this way, you can sort any data frame by ascending or descending order. So next one, here is the explanation I wrote. Sorting the data frame by age and ID variable with missing values appears first. So missing values appear first, meaning what? I write here NA underscore position equal to 5, right? Suppose in this case, after ID, age variable has a missing. So that missing will appear first. Then there will be some kind of dot or NA should be written there. Understand, right? So that is why in the top I wrote sorting data frame by age and ID variable with missing value appears first. And the last one is what? Sorting data frame by age and ID variable with missing values appear last, right? So let us do that one now. So S4 dot head, yeah. So that line of code I'm seeing, it's coming later. But if you expand these things, you will see the pattern we coded, the data is showing up exactly in same format. I'm not showing you right now because that coding I'll show you later. Okay, so now question number 10. Question number is 10. Create a DF1 data frame from D1 data frame by selecting only first visit. By selecting only first visit. Okay, what does that mean? The meaning of that, the person with the ID 50,000, right? And his age was 9.35, right? So, and then his age was 10.34. So this is his first visit, right? According to the age. 10.34 cannot be his first visit, right? Are you understanding? If I visit today and 1 week later, so 1 week later that will have a higher age, right? Yes. So this is the higher age, right? So I want to select first visit of each person. How can I do that? I have a data. The data is 20,900 rows, but that data has altogether just 1,700 or 2,000 persons. Do you understand? 2,000 people, but 20,000 rows. What does that mean? 2,000 people has a multiple visit, right? But each person I want to select only first visit. You understand? Only first visit. So how can I do that? That is why first visit means baseline visit. Suppose I want to study all of us in this room for the next 20 weeks. Okay. So first week is usually denoted as a 0 because that is the base period starting. We want to observe them later. Later time period, how their health status is, we want to observe them. So that is why it is written create a DF1 data frame from D1 data frame by selecting only first visit. So come in here. Finding the maximum of age corresponding to each ID. Okay, this is the different one. I will run that one, but come this one. D1 taking only first visit for each subject. Data must need to be sorted by ID and age variable. What I did, I sorted the data. That data has a name S2. And after that, I S2 dot drop duplicate subset this keep first one. Okay. Let me spend some time in here. My question was that this person, it is his first visit, right? Right? I want to pick only this one. This row I want to pick, and rest of the row for this ID I don't want to. Do you understand? So that is the question is telling you, create a DF1 data frame from D1 data frame by selecting only first row. So I name it as a DF1. First of all, I shorted this. This is the sorting thing I did. Control Z. And then I write this one. Now take a look at that one. DF1 dot head. First person, okay, is this. This person has age that. 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 Okay. So how many unique person is in there? If you want to take a look at that one, you just need to do this. NP dot shape DF1 are you seeing 2,379 persons in 25 column. Okay. Original data was D1, right? Take a look at how the original data looks like. Original data has 20,900 rows. Now it has 2,379 rows. Each unique subject, each unique individual, each unique person has been picked up by running this code. Okay. This is the different thing that I find for one analysis. So it will come maybe. If it will not come, then later I will add this. And then take only last visit for each subject, as S2 is already done. S2 is already done, which is sorting. So we just need to run this one, keep the last one. So that is the way you can find the last one. df2 dot head. Okay. Right. Now let me spend 1 minute in here. Suppose you are given longitudinal data, okay, and you are asked to do some analysis on that. Are you paying attention to my words? Suppose you are given a longitudinal data and you are asked to do a analysis. What you will do? You will first do a base period analysis. Base period analysis means first visit analysis. Okay, you select the subject with the first visit and do some histogram, summary statistics, box plot, all of these. Okay, and then you can do another one. It's called the last visit. Okay, so if there is a 10 visit, first visit will have one type of pattern, last visit will have different type of pattern, right? And then you can argue with your manager, say this is the findings from the first visit, this is from the last visit, and this is the difference between. And also I have done the analysis with the complete data by some kind of predictive modeling known as the linear mixed effect model or something like this. Clear, right? So that is why in scientific paper, they mention what was the findings from the base period, from the first visit, okay? And then they use all the other data, like 9-10 visit data together. They do the predictive modeling. That model has a name known as the linear mixed effect model. Understand? Linear mixed effect model we are going to learn in 580 or 480. Okay. And then 11, 12. Check the names of the variable of S2 data. S2 data. S2 data was created in here. S2 data created was in there. So if you write print S2 dot columns, these are all of your variables. So data sets has how many variables? 25 variables. I want to take a look at the name of the variables. So this is the S2 dot columns. If you write the print, then it is showing up. Okay, the print is coming from the C++. Let me drink little water. This room is very hot. I put a thermal that I forgot. Okay. So another option, you can also write print this, which will print the entire data. And if you write the types of the data will be mentioned. So data S2 is a data frame format. underscore frame data frame. So data S2 is in the data from frame format. What are the other option? Other option is the matrix format. Data could be in the matrix format, data could be in the data frame format. Okay. Sometimes some analysis to be done, data needs to be transferred in the matrix format, and some other cases it should be in the data frame format. Okay, and then checking the variable types. I want to know either the variable is continuous or discrete. So something like this. In order to do that, if we run s2.inform, then it is saying floats and integer. So the ID variable, raise variable, visit variable are integer variable. Rest of the variable are in the format of a quantitative or continuous. Okay. So you need to know the variables are what type. This is an integer variable. This is a quantitative variable, continuous variable. If you want to take a look at the, if you write this one, then they will give you just shortcut name. Previously, it was given variables with if you take a look at the, this is the number of values available. Rest of the things are missing. So TC has the highest number of missing. So only 7,511 person has a total cholesterol values. Rest of them does not have a total cholesterol values. Okay, after that, if you want to take a look at the, we already did these things, head, and that is the tail. And if you want to take a look at head of the first 100 and then tail of the first 100, that is the way you can take a look at this. Okay. Now come to the problem number 16. So we finished so far problem number 15. Now let us consider problem number 16. We can identify people by their ID, right? For example, each and every one of us has a social security number in USA who has a like the legal status of working, right? So social security number is our ID by which we can be identified easily, right? So there is a name. When you will study more in the later stage, you will see you have to sign an agreement known as the NDA. NDA stands for non-disclosure agreement. Non-disclosure agreement documents you have to sign. So what does that means? You are working in the human resources of Google, who has around 70,000 employees, and you are working in the payroll. You cannot pass the secret informations to the employees. Understand? Who is getting 20% increase? Who is getting 10%? Who is getting 1%? Understand? That is performance-based bonus. Okay? So, as an employee there, you cannot disclose because one team, there are 5 persons working with the same designation, like they are all associate director, but one person is getting higher salary compared to the other. In such a cases, the payroll person will disclose those secret informations, then that will be the violations of the job agreement. Okay. So how can I do these things? NDA. Suppose there is a ID variable, and I am the manager. I know the ID of each person, 1, 2, 3, 4. Suppose this is the ID of 100 persons. Okay. What I did in here, I changed this ID to 100 or 9, 100 or 10, 11, right? And then I deleted original ID from the data. Are you understanding? This is the original ID. I am the manager. I created a new ID by adding what? By adding 108 with that, right? So 108 with that, then 110. So I know the 108 is my secret number. That is what I only know. And then after creating a new ID variable, then I give these 5 students to do the analysis of this data. So now they do not know what does that ID mean, 108. If you know I am analyzing your data, what is your ID? Oh no, I did not see any ID with that. You understand? So that public personal information should not be released to the other people. You know Equifax? Have you heard the name Equifax? Credit rating company? Like we got the credit score, right? Equifax, TransUnion, and another one. What is that? I forgot. Credit card companies, like all the credit cards that we are using, how much I am paying, all of our informations are preserved, and those are called the TransUnion, Equifax. I forgot the another one. Experian. Okay, these 3 they, but Equifax accidentally their system was broken and third party stole the social security number and other informations. Now federal government fined them $300 million. Understand? So the reason I'm discussing about NDA, when you will work with the data, please be careful about people's personal identity. Okay, if you work with the healthcare data and you have all the informations of like the Washington DC area, all the information, their health status, senator, congressman, secretary of state, if you disclose that this person has that type of problem, that then his personal medical history you are releasing to the people, right? Then he will sue you, and in that case you will lose your job, you have to give fine, and you will not get fine, you will not be able to find another job. So be careful about handling data when there is a identification variable for the people. Clear? Okay, so what I did in here, so line number 100, take a look at that. S2 is my original data, which has a new ID variable, and from that, which has the ID variable. From the ID variable, I am subtracting 49,999. That is the keyword that I already remember, okay? And then new ID has been created, okay? You understand? So line number 100 is saying that I am creating a new ID variable from the existing ID variable, where I am subtracting 49,999 from each of the ID. S2 dot ID means from the S2 data, I am taking ID variable and subtracting 49,999, and new ID variable has been created. Take a look at that. After running this, now if I show you S2 dot head, take a look. This is my previous ID, now my new ID. Now nobody can understand what is the ID of the individuals, okay? Right? So everything has been changed. Okay. So now I want to delete the original ID variable, because this is the data I have deleted. How? The line number 104 is telling that delete what? Take the S2, take the ID variable from the S2 data and delete that ID variable. Okay? Line 104. Line 104. And then if I run the next one, Take a look at that ID variable is gone. Is there any ID variable in here? No, right? Previously there was a ID variable, now ID variable is gone. Why? Because I'm deleting it. Okay, now question number 18. Report the summary statistics of each variable of the S2 data. What do you mean by summary statistics? Minimum, maximum, first quartile, second quartile, third quartile, median and second quartile are the same. And sometimes now they also started using now standard deviation. Okay, this is called the summary statistics. How can you find that? This is the way you can find the summary statistics. Okay, summary statistics. If you take a look at that, this variable has 20,900 values. Income has 19,742 values. Rest of the values that are missing. Data has altogether 20,900 rows. 20,900 rows. Rest of the values of the income variable are missing. Okay. Okay. Alternatively, you can also run line number 110, and this is the way you can get the summary statistics. Okay. So this is the summary statistics of entire data frame. If you have a data, how to find the summary statistics for the entire data set, entire data frame. Okay. But if you want to find the summary statistics for a variable of interest, suppose SBP, which stands for systolic blood pressure, how can you find that? You can find this just by choosing the SBP variable from S2 data, and between them, between the two dots, you have to put describe and parenthesis. Okay. Take a look at that. Here, two dot, between two dot, I put the describe of summary statistics of this. S2 dot describe of summary statistics of the SBP variable. Okay. Summary statistics of the SBP variable. Okay. Now, number of missing values for each variable. Number of missing values for the each variable. So if we write like this, S2 dot is null dot sum. If we write like this, 118. Line number 118, when I ran, I got this. Race has a 0 missing value. Income has a 1158 missing value. Age has 11 missing values. Smoke has 9,889 missing values. SBP has 206 missing values. What is the code? S2 is my data. Dot is null. Parenthesis dot sum. So I am taking S2 data, and then after taking S2 data, I am declaring dot is null if there is any missing value, and then I put a dot sum. So that means sum, number of missing values for each variable. Okay. Now from there you can immediately say that, well, these three variables, if we include in our analysis, our result might not be accurate, might not be approximately correct, or even may not be correct at all, because TC, total cholesterol, TZ, triglyceride, LDL, HDL has the highest number of missing values. Understand? So if you present these things to the audiences, you said that, well, you are presenting a result including TC, TZ, LDL, and HDL variable, but this variable has a lot of missing. Okay. Almost more than 50%, almost 65% missing values, because total number of observations, total number of like visits with all people is 20,900. Among 20,900, 33,392 is the highest number of missing. So which is around 70% of missing. So with this huge missing, if you do some analysis and present it to the audiences will raise questions that with these missing values, the findings from these 4 variables may not be good. Okay, so missing values is a important topic in statistics. There is a many statistical methods how to find the missing values. For example, predictive mean match, nearest neighborhood search. These are the techniques could be used to substitute, to replace the missing values. Okay, now this is the missing values for the each variable. Okay, now I want to find the missing values for each row. Understand? Missing values for the each row. If you take a look at the question number, find the number of missing values for each variable of the S2 data. Create a variable nmiss for missing values corresponding to each row of the S2 data. Now in the S2 data, for example, let me show you S2 dot head. In this case, I want to write n miss, and there is a number of missing values corresponding to these 7 missing values, corresponding to second row 8 missing values, corresponding to third row 0 missing values. I want to find a column in here. You understand? I want to create a column named n miss, which give number of missing values corresponding to each row. Understand? Which I can do by running line number 122. If line number 122 is run, then I have this. Now take a look what I am writing here. S2 dot head. Are you seeing nmiss is created, right? First row has 1 missing value, second row has 4 missing value, third row has 0 missing, fourth row has 4 missing, fifth row has 0 missing. Understand? How did I write the code? Take a look what code I wrote. S2 is my data. Find is null, but sum by row. Okay, x is equal to 1 means row by row I am summing them. Okay. Okay. Now in the data sets, if there is any missing values, for example, let me write something in there. Suppose this is the, let me try to clarify this thing. This is the ID variable age, and then suppose TC and dot last one, suppose wait, this is the variable. Okay, it has value, it has value, it has value, it is missing, and it has value, missing, it has value, it has missing, and then value, and everything. So I want to delete any row that has a missing value. Do you understand? It should not be missing in entire row. Any row has 1 missing value. For example, let me write this as S2 dot head. Let me see by writing 10. Okay. See, this is missing, right? So that means I want to delete all of these rows. If any row has any missing entry, any row has any missing entry, it is not to be entire row. If any row has any missing entry, so for example, this is the second row. Second row has 1, 2, 3, 4 up to 25 entry. Among these 25 entries, suppose only one entry is missing, I want to delete that row. Okay, so that could be done just by running line number 126, known as S2 dot drop NA. Drop NA. Take a look, significant reductions of the size of the data. Now my data become D2. D2 dot head. D2 dot head. And NP dot shape D2. If I write it in here, take a look at it was previously 20,900 rows. Now it reduced to 1,942 rows. Clear? So 1,942 rows are complete rows. So that means each row has all the values, all 25 values. Okay. So when you are given a data set, do not just think only one way. Okay. You can do one analysis with the first visit. You can do another analysis with the last visit. You can do one analysis with the complete data. And then audience is in there. You can say, start with the audiences. Dear audience, thank you for showing up to my presentations. I have a very big data. In this big data, longitudinal data. So longitudinal data, I did lot of work. I did a first analysis for the base period, and I did another analysis for the last repeated measurement, and I also did a analysis for the complete data, and finally I did analysis for the complete incomplete entire data by using linear mixed effect model. I'm going to show you my findings in next 30 minutes. You understand? Then they will ask you, well, base period I have observed these things, but when I did the final one, I see that this is higher, that is higher, that is higher, because this is the 10 years follow-up data. In this 10 years follow-up data, food habit changed, people blood pressure went up, people height went up. These are the things you can tell. Understand? So when you do the research analysis, research thing, think multiple way to present your findings, or even if there is a one data, you can analyze the data in multiple ways, right? That is what I just said to you. Okay, so now checking the dimension which I just showed you, and then I want to find the summary statistics for the complete data. Okay, previously there is a summary statistics with all data there are missing as well as non-missing. Now I have a summary statistics for the complete data. There is no missing values. Okay. Okay, now question number 25. Find the standard deviation of each variable in the D2 data frame. This is the D2 data I took and just write the STD. Okay. What is the definition of a standard deviation? Distance from the mean. Okay. Okay, distance from the mean. So the standard deviation is written like this format: n minus 1 sum of xi minus x bar square, like this. Okay. See, average distance of each data point from its average. Okay, average distance. So let me tell this. Xi has value to let me write it. Xi has value 100, 99, 1, 0. Okay. So the X bar equal to what? 50, right? X bar equal to 50, right? So now, if I put Xi equal to 1, so this is a distance, right? So that if this is a distance, 100 minus 50 equal to 50, 99 minus 50 equal to 49, 1 minus 50 equal to minus 49, 0 minus 50 equal to minus 50, right? This is. So this is called the distance. And then this is the distance I am taking, and then I am squaring it, and then I am neutralizing it with that. Okay, by taking the square root. Average distance of each data point from its average. Each data point from its distance of each data point from its average. This is just this. Distance of each data point from its average. This is equal to just this. Okay. Distance of each data point from its average is just that one, Xi minus X bar, right? And this average is coming where? When I dividing this one by that quantity. Okay. So now the question is, there are 4 quantity, right? 1, 2, 3, 4, right? But I'm dividing it by 3 quantity, right? 4 minus 1 equal to 3, right? Do you understand? Yeah. I'm saying average distance of each data point from its average. I am dividing it by 3 and minus 1. How did this come into an existence? Because this is called the sample variance. Sample variance. And it is mathematically proved. Sample variance is an unbiased estimate of population variance. Okay? This is coming from unbiasedness concepts. So if someone asks you what is the definition of standard deviation, you will say average distance of each data point from its average. So each variable in the data sets, now I want to find the here. Standard deviation for each data. So D2, which is 25, which is 25 like this. Okay. So now I want to find the standard deviation for the continuous variable. So I write A11. So race, income, smoke, chest measurement, waist, and event. So these are the irrelevant variable in the sense that these are qualitative variable or categorical variable. So I just don't want them to be in my standard deviation computations. Okay. So I want to find the standard deviation for the only continuous variable. See how the line number 141 is written. Pure English, right? Variable for variable in D2 dot columns, if variable not in the irrelevant. What is irrelevant? Irrelevant is this. Okay. When I first find this code, I was laughing. Right? When I first find this code, I was writing these things for this class. I was laughing, see how the people have written it. So variable for variable in D2 is my original data from where I want to subset some continuous variable. So D2 dot columns, if D2 dot columns, in D2 dot columns, if variable not in the relevant. So if variable not in the relevant, so that has a name, that name is relevant. So I put a D2 relevant dot standard deviation. So in that case, it will show the standard deviations for the remaining variables. Okay. Take a look at that. Can you find their race, income, or smoke? Race, income, or smoke? No, right? Because race, income, and smokes are irrelevant variables. Okay. Now, question 26 as find the minimum, mean, standard deviation, and SBP variable for of D2 data frame. So this is the standard deviation of SBP. This is the mean of the SBP. This is the minimum of the SBP. If you want to find each of these for variable in the D2 datasets, that's the way you have to write this. Okay. Okay. Now, question number 27. ABP variable by averaging this. Take a look at that. I have ID variable. I have SBP variable. I have DBP variable. Okay. And then I have TC variable. All the way WT is the variable. I want to create a average blood pressure variable by adding this and that. Understand? By adding SBP and DBP, I want to create these variable. That's, for example, this is the ID, new ID equal to 1. It has suppose 110. It has suppose 90. I want to find, so 110 plus 90 divided by 2 equal to 100. This is what I want to find. Clear? I want to create a variable like that way. Okay. What can I do in here? Take a look. I took SBP and DBP and I name it as an initial. If you don't like initial, you can put your spouse or girlfriend name. Okay? Initial. And then I write here D2 initial dot median. Okay? If there are two numbers, mean and median are the same. Right? So if you have a 20 and 30, measurement 1, measurement 2, 15 and 30, 40 and 60, then 50, this is a 25, 45, this is a 22.5, this is a 100, this is a 50, right? This is for the median as well as mean, right? Are you okay? So that is why I write here as two things there. I just write here median x is equal to 1. Okay, x is equal to 1, and then I have created ABP variable. So now take a look at the data. This is the ABP variable. Clear, right? So now I want to see only three variables in a SBP, DBP, and ABP. These three variable I want to see in a data frame format. So I took this variable and then I put that all within D2 data and see the head. Okay. See how I wrote line 155 and 156 to check only these three variable. Now someone take the calculator. This plus that divided by 2 equal to this plus that divided by 2 equal to that. Okay. You can take a 5 minutes break. 5 to 7 minutes break you can take. I will rest 1 hour. I will. Resume recording. Okay. Okay, now question number 28 is asking you, so here ABP values has been created, right? 100, like 110, and then 115, something like that. So I want to create a BPC, blood pressure category variable. In what sense? It should be 1 if ABP values 100 and above. If 100 and above, then it will be 1. 2 stands for ABP values between 85 and 100 exclusive, and 3 stands for ABP values all other values. So for this case it could be 1, 2 and 3 in such a way that 1 stands for ABP values between 100 and above. 100 and above. So 100 and above means here is 1. So here is maybe 2, 3, something like this, or it is 1, 2, 3. So we want to create a BPC, blood pressure category variable for the problem number 28. This is the way we have to create a blood pressure category variable from the ABP variable that we have just created by averaging SBP and DBP. So in order to do that, let me take you to the code. This is the question number 28. I just write here ABP limit equal to D2 ABP dot maximum. I am taking maximum value and then adding a 1 with that. You can ignore that things, that is okay. But after adding 1, no other ABP value exceed that highest limit value. Understand? So you have $1 million, we know, nothing more than that. Okay. So altogether, he said in my all account, everything together was $1 million. If I say, okay, he said 1 million, just put $100,000 more. So 1,100,000. So above that, there is no value, right? So I can, when I will code, accidentally, if something put above 1 million, then there should not be any value cut off. So that's the reason to get not to cut off. I added a 1 there. If you want, you can take it out. You understand, right? Okay. Huh? Yeah, we can take it. We can delete these things. Okay. Now let us run the code. So now I am creating, if you read line 161, 62, 63, because we will be binning the data using exclusive right binning function. Binning function, yeah, right, binning function. We make sure that highest value is still included in the new categorical level when creating bins. So that is why I put a 1. You understand? So these 3 lines, 161, 162, and 163, give a clear explanation why I added 1 in here. Now I am running it without 1, and then I will run it again with 1. Okay. So then 0 to 85, the level will be 3. 85 to 100, level will be 2. 100 and above limit equal to 1. What is above limit? Above limit equal to D2, and then ABP maximum. Understand, right? Are you seeing above limit, this above limit? So 0 to 85 equal to 3. ABP value falls between 0 to 85, then the blood pressure category level equal to 3. ABP value falls between 85 and 100, blood pressure category equal to 2. ABP value falls between 100 and above ABP limit, then is equal to 1. Understand? Clear?
Yes, sir.
So that ABP value, I just put it a 1 in order to make sure that highest value of the ABP must not be cut off. Clear, right? You are okay now?
So understand this from school.
Ah.
When we say the BPC ranges,
Yeah,
0, it's 5,
it's 0 to 85,
okay?
and then BPC level will be 3. So 0 to 85 and 85 to 100, 100 to ABP level. This is coming from where? This is coming from this ABP value. Are you saying? Then when I finally creating this value, I am putting this value actually coming from there. PD dot card, P2 data and ABP value dot values, and values means BPC ranges. Are you seeing BPC ranges? BPC ranges include lowest falls, like levels, BPC levels, BPC levels. Okay? Clear, right? So take a look at this now. We have a D2 data, D2 dot head. This is the data. There is the ABP values. These are ABP values. Now, if I run this, just let me run this. And then now take a look at the D2 dot head and take a look at that. 2, right? 2 falls where? 2 falls 85 to 100. So this is 85 to 100, 2 falls, right? 1 falls what? 1 falls 100 and above. This is 100 and above, right? Clear? So if you plug in here, that means you are making 100% sure that my highest value will not cut off. Clear? Adding 1 does not mean adding anything in the ABP. With the ABP, I am not adding anything. I am adding highest limit values 1. I'm taking maximum and then putting 1. So that means maximum limit would be that. Within that, the values must come from there, okay? So this is the way any continuous variable, you can transport it as a categorical variable. If there is a continuous variable, how can you record, how can you create a categorical variable from continuous variable? That is the problem number 28, I guess. Okay. Now 29, I want to create a problem number 29, subset D2 data as D21 by selecting TC values greater than 162 and weight values less than 62. In the entire data, if I want to do an analysis of the data where individual has weight less than 62 and total cholesterol greater than 162. So I have a big data. From that big data, I want to subset the data as a short data in which weight less than 62 and total cholesterol values greater than 162. Clear? Okay. Okay. Take a look what I did in here. From the D2 data, I am taking TC and then TC value must be greater than 162. Again, from D2 data, I am taking weight must be less than 62. All of this operation is taking place within D2 data. Within the square bracket of D2, okay? Now we see one line of code are doing lot of things, right? Just one line of code, right? What is the highlighted part is doing the subsetting part. Subsetting part within what? Within D2. Okay? Within D2 subsetting part are taking place. Okay? You are okay? Everyone is okay? This is the D2 data. From the D2 data, I am taking total cholesterol variable. So total cholesterol variable must be greater than that. And D2 data, this is the I am taking D2 data, I am taking weight variable of D2 data and subsetting less than 62. Okay, and then both of these operation will happen within D2 data. Okay. So after running this, if you run this, now if you take a look at the dimension np dot shape D21 1942. Okay. Listen, I give you instruction how to solve these things, right? Read the document, find the code, and then you apply this code for the new data. So the homework data is a new data. Okay. So this is the fundamental thing of any data analysis or data science job. 80% of your work will be for the data cleaning, okay, data editing, and then preparing the data for the predictive modeling. After data preparations, then rest of the efforts is just 20% only for predictive modeling or decision making. Question number 29 is asking you, subset D2 data as D21 by selecting TC value. Okay, this is already done. Construct a frequency table for BPC variable of D2 data. So BPC variable has been created, right? So take a look at the BPC variable. So now I want to find how many will have blood pressure category 2, how many will have blood pressure category 1, how many will have blood pressure category 3. That could be done just running these cross tabulations. Blood pressure category 3, there are 126 persons. Blood pressure category 2, there are 1100 persons. There blood pressure category 1, there are 715 persons. What type of code we write? PD panda dot cross tabulation. Index DT. From D2 data, I am taking BPC variable and I am finding the cross tabulations by column count. I am creating a column of count. Okay. So now how can I do it for the two variable which are BPC and race? This is could be done running again this panda cross tabulation index equal to D2 BPC and column equal to D2 equal to race. So this is the way if you write columns, it will appear race, column, this is the column, race appearing 1 and 2, 1 for the Caucasians, 2 for the African American, okay? And then in the row, blood pressure category is appearing. How can you read this table? So there are 63 Caucasians people with blood pressure category 3. There are 578 African American people with blood pressure category 2. Understand? So this is the way you have to explain. After finding these things, you have to explain to the audiences. Okay? Gentlemen, are you okay? Okay, question number 32. Use the group by function to find mean of D2 data frame for raise variable. By raise variable, so for example, raise 1 and raise 2. For raise 1, what is the mean SBP, mean DBP, mean height, mean weight, all of these things. For the raise 2, I want to get all of this. Clear? So that is what I want to get. So I subset by race, this is by race, and then if I find the mean, that is the mean. Take a look at that. By race, D2 dot group by race. So by race is now group. By race dot mean. By race dot mean for the entire data. Race 1 and race 2. Income, in average income of for the race 1 is that. Average income for the race 2 is that. Average age of the race 1 equal to this. Average age of the race 2 equal to that. Okay? Average blood pressure for the race 1 equal to this. Average blood pressure for the race 2 equal to that. Okay? For the entire data frames for all variables you are looking. Then this is the standard deviation. That is the standard deviation. Okay. Now you want to find the by race mean of a specific variable. Previously, you find the mean for each variable of the data frame. Okay, data frame. This is data frame has how many variables? 25 variables. All 25 variables here. But if you are interested for only one variable, this is the way you can find this. Okay, by race only one variable, line 197. See, just race 1 average SBP is this, race 2 average SBP is that. Okay. You are with me, right? And now I want to find by income and then income. How many income level? 9 income level, right? So if I find the mean for the data frame for the income, you will see 9 rows. You will see 9 rows. Race variable. Take a look at this one. Race variable, income has how many? 9 level, right? So income level 1, race variable has this average. Income level 2, race variable has this. So this may not make sense, but this one will clearly make sense because income level 1, average age is 12.82. Income level 2, average age is 12.93. Okay. You understand, right? What does this mean? Income level 3 has a black race as well as white race, right? Suppose white race is 200 and black race is 100. So 200 plus 100 divided by 2 equal to this number. So income level 3, there are white race which is equal to 1. So that means if there are 200 people, that means 201, right? 1 plus 1 plus 1, 200. And black race has a level 2. If 100 people, so that means 200. So 200 plus 200 equal to 400. So 400 divided by number of people. Okay, so 400 divided by 300 will be the answer for that one. Because 200 white people and 100 black people all together, 300 people, but the level is 400. 400 divided by 300 equal to 1.5. That's the way it is explained. Similarly, this is for the standard deviations by income for the entire data frame. By income mean, okay. Now I want to discuss here. The question number 36 is telling you, are you seeing D2 dot drop duplicate subset equal to new ID? Now take a look at the data, control L, D2 dot head. Are you seeing new ID? New ID, right? So what I am doing in here, D2 data drop duplicate. Drop duplicate means if this is appearing twice, that means repeated measurement is deleting. I will take only one measurement. If ID number is appearing, same ID number is appearing, I will delete, duplicate all, keep only one. Understand? So that is what we are doing in here. If you read the question number 37, create a new D3 data 36, question number 36, create a new D3 data from D2 data by selecting only unique records, unique subjects. D3 data should not have any repeated measurement. So if I run this, and now if you take a look, np.shape.d3 equal to this, and then np.d2 equal to 1942. Okay. So the rationale is from the D2 data, but D2 data is created from where? By subsetting height and see, this is what the D2 data is coming from. Okay. So maybe I can do it. Okay, let me check the original new ID variable when created. Let me check the original new ID variable. Oh, okay, I understand. D2 is created actually after dropping all the missing values. So let me go there. Here is the data. It is coming from S. So np dot hey D2 dot np dot shape D2 1942. So 1942. Now let me go down all the way 37. Yeah. So now come in here. Control enter. And now if I want to find this one, yes, 1440. This 1440 persons, previously it is 1942 by deleting missing values. Are you saying D2 is created from S2 data by deleting any row that has a missing value? Okay, by deleting any row that has a missing value. And this is called the D2 data. D2 data has 1942 rows. From these 1942 rows, any row that has the same ID, I will keep only one and delete the other one. Okay. then my data reduced to 1440. So this is the unique subject. Okay, this is the unique subject. After that, this is called the D3 data. Now I want to find some graph, draw bar chart and pie chart for the variable raise, smoke and income of the D3 data. Okay, bar chart and pie chart. First of all, by cross tabulation, in order to do the bar chart and pie chart, okay, listen, bar chart and pie chart are constructed for the qualitative variable. Okay, qualitative variable means what? Which you can count. Okay, race is a qualitative variable, color is a qualitative variable. Okay, so bar chart and pie chart are constructed for the qualitative variable. We are finding the frequency in line number 17. We find the frequency, and 2018 is a package which we are importing, and then we construct a explode. This is called the, are you seeing plots there? Currently console is highlighted, this console is highlighted. But if I click on there, this is the plot. Okay, this is the plot. Are you seeing these things is jumping out from there? Yeah. This red part. If you do not want that thing, you need to do this. This explode, you can just comment it out and take out this explode from there. Take out this explode from there, and then if you just run this, then figure like this. Okay, okay, now I want to do the bar chart. I want to do the bar chart in here. This is the bar chart. Bar chart for the smoker and non-smoker. Okay. Bar chart for the smoker and non-smoker. Now I want to do the question number 38. Put bar chart and pie chart of the raise variable in a 2x1 grid. 2x1 grid money means there is a 2 row and 1 column. For example, if you want to see figure like this, 2x1, so that means one page, row number 1, row number 2, but column 1. So that is why these 2 means this one means that. Understand, right? Okay, so that is the problem number 38. Let's do the problem number 38 now. I'll give you explanation for this. Are you seeing these things? Now let me explain what does this mean. Are you seeing line number 237 plot, subplot 221? 2 means 2 row, 1 column, first figure. Okay. Then that one means 2 row, 1 column, second figure. That is that subplot title means this is the way we have written these things. Okay. And then if you take COLs means color, red and green, that letter R and G stands for. Letter R and G stands for the red and green. Are you seeing R and G? Okay. R and G. For the bar chart, we did not specify any color, so that is why there is no coloring thing. This is 39, I guess. Now we have to do 2x2 plot of race and smoke variable. 2x2 means 2 row and 2 column. So that means 4 figures. So that is why plot subplot on line 259 is telling you 2, 2, 1, 2 row, 2 column first figure, 2 row, 2 column second figure, 2 row, 2 column third figure, 2 row, 2 column fourth figure. Okay, that's 2, 2, 2, and then 2, 2, 3, then 2, 2, 4. Okay. Let me run here and then I will stop for today. Two, two, one. Here, 2, 2, 1. So let me run this. There is the figure. Okay. So now in your report, if you want, so copy image, you just copy these things. Okay. And then you just go there, class practice document. You can just put this. Are you seeing? Copy this, paste it in there. Then you can write, you have to write a report, right? For this one, you can say that, well, by looking at the bar chart for smoking variable, we notice that the number of smoker, that is not true. That is not true. So I put a wrong labels. It should be here, it should be there. Okay. If you don't believe me, take a look at the frequency. So it should be actually non-smoker is this one and smoker is that one. It should actually go that way. It should change actually. Understand? So when I put this level was in wrong. Okay. So you will say that pie chart and bar chart is clearly telling that non-smoker is way smaller than the smoker. So this is the data is coming from a population which is highly dominated by the smoking people. Which country has the highest number of smokers? Do you know? What? No. America has a strong, very strong policy. I think it is someone in the Caribbean. Someone in the Caribbean has the highest number of. Yeah, you can leave. So if you have a bus that is leaving 8:20, you can leave early. Okay. Which country has
according to
highest
population?
smokers? Nauru. Nauru is a
According to world population.
yeah. That is I think Pacific Island maybe.
Yeah, it's in the Pacific.
It's in the Pacific.
Yes.
So close to Caribbean, yeah, Nauru. Smoking rates by country. Let me see. Nauru, Kiribati, Tuvalu. Myanmar is so high. Chile, Lebanon, Serbia. Oh my goodness. My country, Bangladesh, has a lot of smokers. That's not good. Oh, African people are doing very good actually. Take a look.
Very responsible.
Yeah, very responsible people. I want to find the African people.
America has no countries.
I think if you scroll down further,
South Africa is the country that has the highest. Scroll down.
Yeah, it shows you, it only gives you like, I don't know how many countries that are recognized by the UN.
Okay. United has the, because there is a strong law. You cannot sell cigarette up until 21. It was previously 18, but they changed it. Because health insurance company, they have to pay a lot. And if you start a job, then your company will give you health insurance, then you have to fill out a form whether you smoke or not. If you smoke, your health insurance is $150 higher. Of course. Because of your heart disease, lung cancer, all of these things, they will pay. Okay, that is why you're going to pay.
Ghana has the lowest one.
Ghana is the lowest,
It says 3.7%.
and you are from Ghana?
So, well, the United States,
No, the way you are saying my country. I'm just kidding. But it is surprising, maybe the South Africa has the highest cigarette smoker. South Africa has 31%. Yeah. Let me see which country has the lowest cigarette smoking.
Ghana.
Oh, Ghana.
Yes, it's also different. Ethiopia, Nigeria.
Nigeria is pretty low. Yeah, no, like, do you see that? It's the lowest, but the countries with the lowest are like in West. Well, two in West Africa, one in the East.
How about in terms of women, which countries women? Oh,
Male smoking percent.
how can I short these things? I want to see in terms of women. See, 40% is Chile.
Trying to find like which country has.
Oh, Nairu, women is more smoker than men.
Wow. But it also said here that Kiribati has like. For some reason, it says here Kiribati is like 70, or no, that's Myanmar, it has 70.2%.
That's 70% switch down.
Okay, do you want me to upload this record, video?
Yes.